Alright guys, here is the video on exploring quadratic, and I spelled that wrong. Forgot my R. Quadratic. Okay, relationships in tables. Alright, so we did this in class today, so it's kind of going over the notes. So we have two tables here. Remember we talked about whenever you have a table, the first thing that you always want to do is look for some sort of a pattern. And the way that you look for a pattern is that you try to find a difference in your y values. Okay, so if you look at the difference between 1 and -1, you're adding 2. If you're going from 1 to 3, you're adding 2 again. From 3 to 5, adding 2. 5 to 7. Okay, so if you notice, it's going up by 2 every time, right? So this is what we call a linear function, right? Because it has a constant difference, right? So remember we talked about slope is your change in y over your change in x. So this is going up by 1, excuse me. So this is going up by 1 every time. So this will actually have a slope, which is 2 over 1. Okay, so you look at this difference right here. If it is constant, then that means that it is a linear function. Okay, so we've done those. You guys should be fairly aware of that. All right, so let's look at this next one. So we're looking at the table, same thing we're going to look here. So from 13 to 8, we are going down by 5. From 8 to 5, we're going down by 3. From 5 to 4, down by 1. 4 to 5, we're adding 1, and from 5 to 8, we're adding 3. Alright, the first thing you notice is that this right here is not a constant difference, because first you're going down by 5, by 3, by 1, then going back up by 1, and up by 3. So right away that you know that this is not a linear function because the difference is not constant. Right, so now what you're going to do is you're going to find the difference between these numbers over here. So the difference between -5 and 3 is +2. The difference between -3 and -1 is also +2. Okay, so you see a pattern, +2, +2. Alright, now if you're looking at this first part right here, this is called your first difference. Okay? And it's the first difference because it's the first thing that you look at. So this is your first difference. Once you notice that it is not constant, that it's not the same, you say to yourself, okay, it is not linear. I know it's not linear. But now you need to show that it is quadratic. Now the way that you do that is you look over here, and this is your second difference. Okay? If your second difference has a constant change, right, so your constant change is 2, that means that it is a quadratic. I'm going to write it up here. Okay, so I want you to think about something. If it's your first difference, right, our our linear function is y equals mx plus b. Okay, so we've just got this x by itself. It's just 1 degree of x. So since you're doing the first difference is just equivalent to an x by itself, or you can also say x to the first power, if my pen will work. Okay, x to the first power. Now if you're going to the second difference, right, think about our quadratic formula, our standard formula. I don't know if I can write it down here. Y equals ax squared plus bx plus c. And remember yesterday we talked about this squared right here is what tells you that it's a quadratic formula. So because you're going to your second difference, that's like saying x to the second power. So because you have an x squared, you know that it's going to be quadratic. Now you should always go through and verify that it does have the same second difference, because they might set it up to where the first difference isn't constant, the second difference isn't constant, so you'd have to check for your third distance. Okay? Alright, so let's go ahead and I'm just going to pull up this table again on B, and we're going to talk about finding all the things in there. Okay, so this is the table that we just worked on, and we knew that it was quadratic. Okay, so if it's quadratic, remember that that means that it is going to be a parabola, right? Okay, if it's linear, it's a straight line. If it's quadratic, it's a parabola. So that means that it's either going to look like this, or it's going to look like this. Okay, so we're going to go under the assumption that it's going up, okay? So we're going to do a parabola like this. Alright, so now we talked about a parabola has a vertex. Okay, the vertex is your minimum or maximum point, right? In this case, it's going to be our minimum point, okay, because it's at the bottom. And every parabola is symmetrical, so that means it's got an axis of symmetry that goes through it. Okay, so that means that if you fold it over on that line, it's going to fold the parabola exactly in half. Okay, so the vertex is the only point that does not have a mirror image. Okay, so if you're doing a parabola, if the y-coordinate on this one is 4, then the y-coordinate on this one has to be 4 also. It has a mirror image. If this one is 6, this one also has to be 6. If this one's 8, then this has to be 8. The x values can be different, but the distance between the 4 and the 4 is consistent with the distance between the 6 and the 6. Okay, so they have a mirror image of each other. Alright, so when you're looking at the table, you want to look for your y values and see what they mirror. So if you look, you have a 13 and a 13. Okay, so those are mirror images of each other. You've got an 8 and an 8. Those are mirror images of each other. And then you've got a 5 and a 5. Okay, so now you've got this 4 out here all by itself, right? So remember what I said, the vertex does not have a mirror image because it is the one at the bottom. So therefore, this one right here has to be the vertex. Okay, so now let's look at a couple more things. I'm going to go ahead and erase this. Alright, so if we go back, I'm going to write some stuff that was on the table real quick. Alright, so we did our differences, right? This was -5, -3, -1, +1, +3, and +5. Alright, so it's asking us, we know our vertex, so our vertex is -1, 4. Okay, it wants to know if it's a minimum or a maximum, because remember, a parabola can either look like this or like this. This is a max, that's a min. So we need to figure out what direction is it going. Now you can go to the graph and you can graph it, or you can think that it's going from a negative to a positive, so that means it's going down, right? Then it hits -1, and then it goes back up, +1, +3, +5. Okay, so that means that it is going up, and this has a minimum value. Okay? Alright, then it asks you for the axis of symmetry. Right? Remember, the axis of symmetry goes through the vertex point. Okay? So that means that whatever your x value on your vertex point is, your axis of symmetry is equal to x equals -1. That's the equation of that blue line right there. Alright? And it doesn't ask you in the paper for the domain and range, but remember, the domain of any parabola that goes up or down is going to be all real numbers. Okay? And then the range is going to be the same as your y value, because remember, this is your minimum point. So if it's a minimum, that means that y has to be greater than or equal to, because it can be this point and anything above it, to 4, because this coordinate right here has a y coordinate of 4. Okay? Alright, so let's do one more, just to kind of go over what we did yesterday with the, or tonight with the points. Alright, give me a sec. Alright, so this one is talking about same thing. We're going to figure out whether or not it's quadratic or if it's linear. Alright, so we're going to find our differences. The difference from here, from 19 to 11, is plus 8. Then from negative 11 to negative 5 is plus 6. Then we got plus 4, plus 2, plus nothing, 0, and then minus 2. Alright, so we know that our first difference is not the same, so it is not linear. Okay, so now we're going to verify that it is quadratic. So you find your second difference. This is minus 2, right? So our second difference is the same. Okay, now when you're doing a problem, you don't necessarily have to find the differences for all the points. You could do it at least for the first 3 just to verify it. Okay, but just when we're starting, once you get into the habit of doing it for all of them. Alright, now, so let's look at something here. Remember from the last one, we went through and we looked at the mirror images. Okay, so let's go ahead and do that. So when you're looking at this, you have to understand, okay, so if this table was extended, remember a parabola has infinite amount of points, right, starting at the minimum or maximum and then going up or down. So if this table were to continue, if you look, right, we have our 1 and our 1, and then we've got our negative 1, negative 1. So if this is a negative 5, then this would have to be a negative 5. If this is a negative 11, you'd have to have a negative 11 there, and then a negative 19. Okay, now obviously not all of those points are on there. Oh, I gotta erase these circles first. Okay, so we would have negative 5, negative 11, and negative 19, and then we're still going up by 1, so 4, 5, 6. Okay, the pattern's going to continue, but this part right here just wasn't given. Alright, so now we're going to look for our matches, our mirror images. Alright, so 19 matches with 19, right? Negative 11 matches with negative 11, right? So we're just kind of working our way backwards to see. Negative 1 to negative 1. And then we've got here our 1 and our 1. Okay, so there's nothing in between, right? But there's got to be something in between. So if these are my coordinates, if I have x and I have y, and my coordinates are 1, 1, let me erase this. If my coordinates are 1, 1, and 2, 1, let me write this down here, and 2, 1, right, my vertex has got to be somewhere in between there. Okay, so my vertex has to be some number in between. Okay, so I want you to think about it. Let's go through and we're just going to graph something just to kind of make it easier. Alright, let me make this smaller. Okay, so there's my table. Alright, so let's go ahead and let's graph. So I've got just this graph, and it's just going to be kind of makeshift. Okay, so let's graph the points. We're not going to graph all of them. Let's just start at the first one. We'll do 1, 1, so that one goes there. Then we do 2, 2, 1. Okay, and we'll go back the other way. So then we've got 1, 2, 3, negative 1 right there. And then we've got 0, negative 1. Okay, so we all know that the parabola is going to look either like this or like that. Okay, so looking at our drawing, it's getting smaller as it gets to the top. So our parabola is going to look something like that. Okay, so if it has an axis of symmetry, right, that goes through the vertex, whatever that happens to be, and that's not a good example because it's not exactly over. Okay, so if the axis of symmetry goes down the middle, that means that this point right here has to be exactly in between this point and this point. Right, so if this point is 1 and this point over here is 2, the number in between is 1.5. Okay, so that means that our x coordinate of our vertex is 1.5. Okay, now we talked about in class that we're not going to get the exact y. We're going to talk about how you can do that tomorrow. but I just want you to be able to estimate. You know that your y value has to be greater than, greater than 1 because it's above it. So we're just going to put it as 2. Okay? So this right here is our vertex, right? And then just to review, if our vertex is 1.5 and 2, okay, we know that the axis of symmetry is x equals 1.5. Okay, the domain is all real numbers. The range is y. Oh, we have to go back and see, is this a min or a max? Okay, it's starting, it's going up, right? This is our graph. So this is a max. So it's got a max. So we know that our y is less than or equal to approximately 2 because we're kind of estimating that. Okay? Alright, so you're going to do 1 through 6 on the other page, and we're going to talk about it in class and use the calculator. Okay, I will see you guys tomorrow in class. Have a good night. Bye.